Picking back up where we were yesterday, we're going to take a look at A. Now, I did D yesterday because there was a lot more involved than in A. So with A, I am trying to determine who has the larger value. And the larger value is underneath the Y. So the larger value is underneath the Y. That tells me I'm running parallel to the Y-axis. So my major axis, or my axis, is going to be running parallel to the Y-axis. So if, this is just a side note, if these two values right here were exactly the same, then we actually have a circle. Okay, so if those two values were the same, you actually have a circle. Just as a little side note. They're not the same, so we know that it's an ellipse. So the first thing I'm going to do is determine what my center is. So my center is h comma k, where this is x minus h and y minus k. So my center is at positive 3 and negative 1, because it's always the opposite sign. Now, the other thing is that since this is the larger number, that equals a squared. That is a squared. So a squared is equal to 9. That means that my a happens to be 3. And then my b squared is equal to 4. That means my b is equal to 2. Now, I'm not putting the plus and minus on it, simply because that a is the distance. So that's why I'm not putting the plus and minus on it. It is simply the distance. So what I do is I start with my graph, and I'm going to go to positive 3, and I'm going to go to negative 1, and here's where my center is. Now, I don't memorize any of the formulas. I don't. What I do know is that my major axis is running along parallel to the y-axis. So I just put that major axis down there to remind me that from the center, which is again 3 comma negative 1, I need to go 3 in each direction along that major axis. So from the center, I just count 3. 1, 2, 3. So here's where my vertex is. And notice I didn't have to memorize anything. My x value didn't change, so my x value is still 3. And what I did was I just added 3 to that negative 1, so I end up at 3 comma 2. Notice I'm not memorizing anything. I don't want to memorize anything. I got other stuff I have to memorize. So then from the center, I need to find my other vertices, so I go down 3. 1, 2, 3. So here's where my other vertex is. Now notice my y value is not changing, and my my x value is not changing, my y value is. And so I've taken negative 1 and I've subtracted 3 from it. So that's where my vertices are. These are my majors. My minors are going to run along here. That's where my minors are going to run along. And my minors, again, I'm not going to memorize anything. I don't want to memorize anything. What I do know is from the center along the minors, I'm going to count out 2 in each direction. So I'm going to count 2, 1, 2. So this is where my minor vertex is. This minor vertex, this time the x's are changing, so it's 5 comma negative 1. That's where my minor is. And going in the other direction, I'm counting just 2, 1, 2. So my other minor is right there, which is at positive 1 comma negative 1. So I can draw my ellipse right now. And notice I didn't memorize anything, because that's all about distances. I'm not memorizing a darn thing if I can help it. The other thing that I have to put in play here is my foci. Now I know my foci has to be on that yellow line I drew, because that's where my major axis is. That yellow line is where my major axis is. So I have to find my foci, and I have this formula that says c squared is equal to a squared minus b squared. And again, I probably almost never even talk about a and b at all when I'm doing the graphing. What I know is I have to have the larger number minus the smaller number, or I'm in the land of complex, and we're not there right now. So I know that this is going to be 9 minus 4. C squared is going to be equal to that. That means c has to be the square root of 5. So remember, c is the distance from the center to the foci. So that's how come I'm just going to take the positive of it, because we are talking distances. So again, I go back to where my center is, which is right here. From my center, I'm going to add to the y value, because it's running parallel to the y, I'm going to add the square root of 5. So I know my answer is going to be somewhere about right here. I don't know where square root of 5 is. It's more than 2, less than 3. So this is the point. This is my foci right there. My foci is going to be 3 because I'm not changing my x value at all. I'm just changing my y value. So it is going to be -1 plus the square root of 5. And the same thing here is I'm going to go down from the center. I don't know where it is. I'm just going to mark it there. So this is my other foci. My other foci is at 3, not changing because I am just going strictly up and down. I'm going vertically, so my x value is not changing. And then I have -1 minus the square root of 5. And now I've got everything that I need. And notice I didn't have to memorize anything. What I did have to know is that C represents a distance from the center, A represents a distance from the center, and B represents a distance from the center. Okay, how is that? Yes?
Can you please do a quick run through right after you got a squared and b squared, and then you went 3 -1, and I kind of was just copying that kind of off that one.
Okay, do you mind if I do another example? And Jaden, did you have a question? Okay. So I'm going to do another example. I'm going to do B. Actually, I'll just leave that there for a few minutes. With B, I have to have it equal to 1. Is it equal to 1 right now? No. So the first thing I'm going to do is equal to this 1, so I have to divide everything by 16. Now it's going to be equal to 1. Now I can actually start doing the work on it. So this is going to be equal to, and I do have to reduce. 4 goes into 4 once, 4 goes into 16 4 times. So I do have to do that reduction. I have two things that have to happen. I have to have the coefficients on the x's and y's to be 1, and I have to have it equal 1. And so I end up with x minus 3 squared over 4 plus y plus 2 squared over 16 is equal to 1. That's the form that I need. So I'll stop. Is there any questions as to why I did that step?
Yeah, why does it have to equal 1?
Because that's the way that we have the standard form of an ellipse, is always equals 1.
How can you get -1 over on the last one? I followed you with -5, but -1, how can you get -1?
On my last example, okay, well actually this will answer it here too. So again, the reason I have to have it equal 1 is because the standard form of this is x minus h, the quantity squared, over some number, plus y minus k squared over some number is equal to 1. Now the reason I left those blank is because it could be A, it could be B. It just doesn't matter which one is there, just the larger number. So the one I'm specifically working on now, my A value, or the larger value, is underneath the y part. So this would have been the A squared, and this would have been this B squared. So I have to have it in this form. If it's not in this form, I can't even talk about what the center is, what the A's and B's are, or anything like that. So it has to be in this form. And it doesn't matter if that would have been B squared and that would have been A squared. The only difference is that if the larger number is underneath the x part, then I'm running parallel to the y, or the x-axis. If my large number is underneath the large number being A, if my larger number is underneath the y, then I'm running parallel to the y-axis. Now the other part about this is that it is of the form center of h comma k. I have x minus h, but it is a positive h. I have x minus k, but it is a positive k. So it is always the opposite sign that's there. So when I'm coming back to this example, I know my center has to have those opposite signs. Well, what's the opposite of 3? Negative 3. 3. What's the opposite of positive 2? Negative 2. So your center is always the opposite sign. So that's why on my previous example, I had a -1. Okay? Is there any other questions before we keep working on this one? Okay, cool. So then what I do is I start the drawing process. Even if I'm not required to draw, I do the drawing process, so I make sure I'm going in the right direction. So I have positive 3 again, and then negative 2. So right here is where my center is. My center is positive 3 and negative 2. My larger number is yet again underneath the y. That means my major, I'm going to draw it in yellow, my major is along that yellow line because my larger number is underneath the y. So that is the distance I'm going to travel is going to be along the y or parallel to the y to find my major vertices. My major axis is in the yellow line. Is there any questions so far? Okay. So then I take a look at this portion. That is a squared. A squared is the larger number, and in this case it's underneath the y part. So if that is a squared, what must a be? 4. So a is 4. That means from the center, along that yellow line, I'm going to run 4 in each direction. Who's changing, the x or the y? The y. So I'm going to add 4 and subtract 4 from that negative 2. So from this center, I'm going to go up 4, and so I have 3, 2. Notice I am not memorizing anything. And then from the center, I'm going to go down 4. 3 is not changing, so it is 3, negative 6. So I have found my major vertices. I am then going to go back to this, and that represents what? What does that 4 represent? It represents b squared. So what does b have to equal? 2. My minor axis is on that green line. So who's changing for my minors, my x value or my y value? My x value is changing. So I'm going to take that positive 3 and I'm going to subtract 2 or add 2. So my minor here is going to be the point 1, negative 2. My other one is going to be here, which is 5, negative 2. Any questions? Yes?
How do you know if B is 2, like I get that one, well, kind of. I just don't know how to know where the lines go. Does it just go through the origin?
The majors and minors? So the majors and minors always have to go through my center. So the majors and minor axes always go through wherever my center is. If my center is the origin, then my majors and minors are along the x and y axes. But my majors and minors have to go through the center. To determine which one is the major, I look for the one that has the larger number. So the y part has the larger number, so I know that my major is going to be running parallel to the y-axis. So that's why I drew the line running parallel to the y-axis, but through that center. The smaller number, in this case, happens to be underneath the x. And so my minor is going to go through the center, and it's going to run parallel to the x-axis. If those numbers in the denominator would have been switched, so if that number would have been 16 underneath the x part, then my major would have been running along the x-axis.
So do you not, do anything with the b equals 2 or a equals 4?
No, I only have to use that if I don't have the equation. So I'm trying to build the equation, then I have to use that. 2 times my a is the length of my major, and 2 times my b is the length of my minor. Then I might have to use that. But because I have the equation, I don't need that. But I do know it's still true, right? Is that if my 2 times my b is going to be the length of my minor, what was my b on this one? 2. So it's 2 times 2 is equal to 4. Well, I come over here, and from here, from 1 to 5, have I traveled a distance of 4? I have, so that does check that I'm working that right. So it's a good check, but I don't necessarily need it. Yes?
The center is just always the opposite of your H and K?
Yep.
Why is it squared?
Why is what squared?
Like squaring it, does it change the value of h and k?
No. Let me ask you this. This is why. Let me go over here, then we're going to just kind of digress to pre-calc 1 stuff. If I asked you to find f of x is equal to x squared, you would tell me it looks like this, yes? Probably. That's what you tell me it'd look like. If I told you that g of x is equal to x minus 1 squared, where is my x-intercept changing to? It went to the right one, right? It went right here, and so it's going to look like this. So I had it here, I have an intercept of 1, 0. Before, I had an intercept of 0, 0. Notice it is x minus 1 squared, but I am actually moving to the right. 1. So the same kind of thing is happening to these. That is the opposite of that. So going back to this, finishing where the foci are. My foci, c squared is equal to a squared minus b squared. We are chasing c squared. And I personally am not going to memorize a and b. I just know a has to be the larger number, otherwise I'm going to have a complex answer. And we don't want that. So it is 16 c squared is equal to 16 minus 4. C squared is equal to 12. So c is equal to the square root of 12. Which I can simplify if I'm inclined. That's going to be 2 root 3, if I want to simplify. Now, to find where the foci are, again, I'm not going to memorize anything. I don't want to memorize it. So I'm just going to go from the center along the major axes. And if I'm going from the center and along the major axes, if I'm adding that 2 square root of 3, am I adding it to the x part or the y part in this case? I'm adding it to the y part. So I know where my foci here, so this is my foci, and here is going to be my foci. So I'm going to draw my ellipse. This is like the best ellipse you've ever seen. But my foci, my top foci, is going to be 3 not changing, negative 2 plus 2 root 3, wherever that number is. And then my bottom foci is going to be 3, negative 2 minus 2 root 3. How was that? Okay. Now, if there's no more questions, then I'm going to have you do the last one, which is C, and you have to complete the square to do this one.
So we don't actually have to do that subtraction, we just do it right there?
Well, yeah, because I don't know what it is. I don't know where root 3 is. I know it's more than 1 less than 2. I multiply that by 2. So I have some number more than 1 less than 2 multiplied by 2. I'm going to add it to negative 1. I'm going to subtract it to negative 1. I don't know where it is exactly, but I could put in my calculator if I had to figure out where it is. Yes?
Why isn't it just foci 3, 2 or 3 as your thing? Why is it negative 2 plus 2?
Because I always add 2 from it is the distance from my center.
So you keep the original values and then you just add on the negative 2, or that.
In this case, because my major is running parallel to my y, then I'm adding and subtract that foci value, that distance, that c, to the k part of my vertex. Now, if it would have been running parallel to the x, I would have been adding and subtracted to my x part.
K is for y and h is for x.
Yes. All right. Anything else? Cool. All right. Here's C for you all. Please do C. I'm going to just kind of pause it for a few minutes. Go through this. All right. Let's take a look at C. So unlike A, which was good to go and ready to rock and roll, unlike B, where we had to do one step to get it to rock and roll, C, it is more than just going right to the equation. This is going to be a couple of steps. So the first thing you are going to do is write it so that your x's and y's are together. So I'm just going to go over here and rewrite this as x squared plus 6x plus 9y squared minus 18y plus 9 is equal to 0. Now, I'm going to start completing the square, and the way I do that is anything that is not attached to an x or y does need to go to the other side of the equal sign. So I'm going to rewrite this as x squared plus 6x plus some value and then plus, and I need to have the coefficient on that y to be 1. So y squared has to have a coefficient of 1, so I'm going to factor out the y squared. Now I'm factoring out that 9 off of both the y and the y squared, so this becomes minus 2y plus something. And then I'm going to bring that 9 to the other side. So I have to bring the 9 to the other side, so it is minus 9. And then it's going to be plus that first something, and then it's going to be plus that second blank. Now, pay attention to the fact that this 9 and that blank are being multiplied together. So what I add on the other side is both a blank and a 9, so plus 9 multiplied by that blank. Okay, so those have to be there. Now, I'm going to complete the square. The way in which I complete the square is I take the value on the linear factor, or the linear term, in this case, the 6x. I take that number, which is 6, I divide it by 2, and then I square it. And that's what's going to go here, and that's what's going to go here. In this case, it's 9. On the next one, I'm going to do the same thing. I take negative 2, I divide by 2, and I square it. So I'm going to add 1 here, and then 1 times 9, or 1 times 9 on the other side. How are we doing? All right. So what ends up happening on this grouping, the first grouping, let me do it in blue, this grouping ends up becoming x plus 3 squared. My second grouping, which is this one right here, ends up becoming y, there's a 9 in front, 9y minus 1 squared. And then on the other side, I have negative 9 plus 9 more, so I just get 9. And the reason it's a minus 1 is because I took negative 2 and divided it by 2. So whatever number I take and divide by 2 is what goes here. So the number negative 2 divided by 2 is what goes here. The number 6 divided by 2 is what goes there. So there's no real work on that. As soon as you just figure out what the middle term is, divide by 2, that's what it's going to be, x minus or y plus or x minus. So now the last step is I do need to divide each thing by 9 because it has to be equal to 1. And so I end up with x plus 3 squared over 9 plus y minus 1 squared over 1 is equal to 1. Where is my center on this? Negative 3. So my center is negative 3 and positive 1. So even if I'm not asked to graph it, I'm going to graph it because I don't want to memorize stuff. So I'm going to graph this. I'm going to go to negative 3 and positive 1. So there's where my center is. Where is the larger number? Is it underneath the x or is it underneath the y? It's underneath the x this time. And so my major, again I write in yellow, is where my major axis is going to run parallel to the x-axis this time. So I need to go and find out a squared is equal to 9, so a has to be equal to 3. My center, again, is negative 3, 1. I'm going to add and subtract 3 from the x value or the y value. The x value, because I'm running parallel to the x-axis. So I'm going to add 3 and I'm going to subtract 3. When I add 3, my vertice on this side ends up being at 0, 1. I'm going to add 3 to the other, or subtract 3 from the other side, and so my vertice on the other side happens to be negative 6, 1. My minors, I'm going to do in green, is going to run parallel to the y-axis. So I go back up here and I say, okay, well, b squared is equal to 1. That means b has to equal 1. So my minors, am I going to add that 1 and subtract that 1 from the x part or the y part for my minors? I'm going to do it from the y. So my minors, I'm going to go down 1 and up 1. So here's what my ellipse looks like. My ellipse minors on this side is going to be the point 0, comma, -3. My minor up above is going to be at the point -3, comma, 2. The last thing I have to do is find my foci. So c squared is going to be equal to my larger number minus my smaller number. Yes?
For that bottom point, it's -3, 0.
Yeah, thank you. That's what happens when I'm not feeling well. Or I'm just sketchy, one or the other. I am sketchy. Okay. It's just when you thought you got it, I messed you up. Okay, so 9 minus 1. So my larger number squared minus my smaller number squared. So my c is going to be equal to the square root of 8, or 2 root 2. What am I going to add that to? I'm going to add that to the x part of my center or the y part of my center? So my foci are at the point -3 on the left, minus 2 root 2, comma 1. My foci on the right is -3 plus 2 root 2, comma 1. How are we doing? All right. So these last couple of examples here are looking at the equation where you have to build the equation. Now, once again, I don't memorize anything, but I do draw stuff all day long. I like to draw, and I'm not very good at it, but I like to draw. So they're telling me where the center is, they're telling me where a vertex is, and they're telling me where a focus is. So I'm going to draw the picture that matches that. They tell me the center is at +2, -2. So here's where my center is. They're telling me my vertex is at 7, -2. So which way is my orientation? Am I running parallel to the x or am I running parallel to the y? So I know that my major, again, is in yellow and it's running in that direction. What is the distance I traveled from the center to the vertex? 5. So that is my a value. This distance I traveled was 5. That is my a value. That larger number needs to go underneath the x or the y? The x. So where I am so far is I have x minus 2, the quantity squared, over 25, because it always is a squared. And then plus y plus 2, the quantity squared over something, is equal to 1. My foci is at 4, -2. So here's where my foci is. How far did I travel from my center to my foci? 2. That is my c value. I traveled from my center, my foci, 2. So 2 is equal to c. I am chasing b. That's the only thing I need. So I'm chasing b. So I know that c squared is equal to a squared minus b squared all day long. So rearranging this, because I'm solving for b, so b squared is equal to, I'm just moving b to the left, so I'm adding b, subtracting c, a squared minus c squared. B squared is equal to a squared, which was 25, minus c squared, which is 4. B squared is equal to, what is it? Thank you, 21. So that's all I was missing. Now it is asking me to graph it. So if I graph it, I know that, even if they didn't ask me to graph it, I always draw the graph so I know which way I'm running parallel. I then have my foci the same distance and my center, or my vertices the same distance. My square root of 21, and so it's going to look something like that, give or take. I'm going to do one more, and then eccentricity. We're going to talk about that later in this section, so we don't have to worry about it. So I am finished with this section after I do one more. Which one of these would you like me to do, A or B, or B or C? B. Okay. So once again, I always draw and I'm doing B. I always draw what I'm given. I have a foci at 5, 1. So here's where a foci is. And I have another foci at -1, 1. Which way am I running? Yes.
This is just about the previous problem. I had a question about the c squared.
Uh-huh.
Wouldn't the c squared be 16 instead of 4? So it'd be 25 minus 16 because 4 would be equal to c.
So C, isn't C 2?
Like how we had the a squared minus c squared.
Right, but isn't C 2?
Is
Isn't C 2? I am sketchy. Is C 2? Is it something? Is it C 4? Is it 2 or 4? 2. Because you got to check me. I am sketchy. Absolutely check me. Sometimes I don't know what I'm talking about. I'm just making shit up just to see if you guys pay attention. But is it? It is 2, right? So 25 minus 4 is 21, right? We cool? Okay. Okay, you got it. I am sketchy. Okay, which one am I running on this one? I'm running parallel again with the X. How do I find my center?
How did you do that?
Because my foci have to be on that major axis. How do I find my center?
You just get it together.
Am I given the center? We're doing B right here. Am I given the center? No. How do I find my center? What's halfway between these two numbers? What's halfway between these two numbers? So I traveled a distance. I traveled a distance of 6, right? From foci to foci. That means halfway between that would have been 3. So from one side or the other, just count 3. So 1, 2, 3. Here's my center. See how there's no work there? So my center is at 2, 1. They're also telling me that I'm doing B here. They tell me my major is 8. The length of my major is 8. So what does A have to be? 4. Because they tell me that my length is equal to 8, which is equal to 2 times A. So A has to equal 4. And then it's just like we did before, just trying to find the extra missing pieces. So I know that I have X minus 2 squared over 16 plus Y minus 1 squared over something, and just equals 1, and I find that something like I did before. Have a great day, you all. Let's take just a moment to talk about the eccentricity of an ellipse. We're going to hit this further when we get into polar coordinates, and we do these with, we graph conic sections with polar equations. So the way that we define the eccentricity, E, it is equal to my C value, which is the distance from the center to the foci, divided by A, which is the distance from the center to a major vertice. So for an ellipse that has a C value that is less than A, that's going to happen for all ellipses, but is greater than 0. So what we know is that my eccentricity has to run between 0 and 1, obviously not 0 and not 1. The closer that my eccentricity is to 0, the more circular the shape is, and when the closer my eccentricity is to 1, the ellipse is more flat. So if I were to look at this, I know that the eccentricity of this particular one, this E value, is going to be closer to 1 because it is a flatter shape than the eccentricity of this one. This one, if I compare the two, would be closer to 0 because it's a more circular shape than the other one. Again, we will look at eccentricity when we get into polar equations and polar coordinates.